question at hand involves a new building where the electrical inspector rejected the service installation due to a conflict between a local flood ordinance and the National Electrical Code, specifically NEC 404.8. The drawing showed the service on the back of the building with no mention of the flood mounting heights. The inspector is requiring the service to be mounted 3 feet higher than shown, violating the NEC, which states the height of the switching handle must be 6 feet 7 inches or less. The building design did not provide for any type of platform to allow compliance with the NEC. The electrical inspector stated that he would accept extended poles to operate the switch as long as the fuses do not exceed 6 feet 6 inches in height. The fundamental issue is whether Section 90.4 can supersede mandatory code rules and allow for the use of extended poles. The building design drawings seemingly did not account for compliance with both flood level and NEC codes. Mounting the equipment to comply with the flood level appears to result in a violation of NEC 404.8. Let's consider the relevant codes and standards. NEC 404.8 addresses clearance requirements for operating switches and circuit breakers. Section 90.4 discusses alternative methods and materials. The electrical inspector's interpretation is that the local flood mounting ordinance takes precedence over the NEC requirement of a maximum 6 foot 7 inch clearance to switch handles. The inspector has proposed accepting extended poles for switch operation provided the fuses are accessible below 6 feet 6 inches. NEC 90.4 permits the use of alternative methods and materials if it can be demonstrated that they provide an equivalent level of safety compared to the code's prescriptive requirements. The critical question is whether mounting the service 3 feet higher and employing extended poles achieves an equivalent level of safety to the standard 6 foot 7 inch handle height requirement. The building design's oversight in addressing the potential conflict between flood level and NEC requirements presents a significant challenge. Potential solutions include firstly, revising the building design. This involves exploring options to modify the building design to incorporate a platform or other structure that allows compliance with both the flood mounting height and the NEC requirements for switch handle accessibility. Secondly, negotiating with the inspector. This entails a discussion with the inspector regarding the limitations imposed by the building design. It also involves presenting evidence that demonstrates the proposed alternative measures, such as extended poles, provide an equivalent level of safety to the prescribed code requirements. Thirdly, obtaining a variance. If a compromise cannot be reached with the inspector, applying for a variance from the local flood mounting ordinance could be considered. This process typically requires submitting a detailed plan and demonstrating that strict compliance with the ordinance would create an undue hardship. Fourthly, contacting the AHJ, the authority having jurisdiction. Reaching out to the local building department or code enforcement agency for guidance and clarification on the interpretation of both the flood ordinance and the NEC is advisable. Additional considerations include a careful review of the inspector's interpretation of the flood ordinance. Ensure that the interpretation aligns with the actual language and intent of the ordinance. If extended poles are implemented, verify that they are properly rated for the voltage and amperage of the service equipment. Furthermore, carefully consider the accessibility and safety implications of operating switches using extended poles, particularly in emergency situations. A comprehensive approach is needed to resolve this conflict. This involves a thorough understanding of the relevant codes, open communication with the inspector, and exploration of alternative solutions that prioritize both safety and code compliance. The key is to demonstrate that any proposed deviation from the NEC provides an equivalent level of safety. Now let's delve into the technical details and considerations surrounding each of these potential solutions. Revising the building design might involve several strategies. One option is to integrate a permanent platform or elevated walkway into the building structure that provides a stable and accessible surface for operating the service disconnect switch at the required height. The platform should be designed to meet all applicable building code requirements for structural integrity, load-bearing capacity, and fall protection. Another approach could be to relocate the service equipment to a different location on the building where the ground elevation is naturally higher, thus eliminating the need for excessive mounting heights. However, This relocation would need to comply with all other NEC requirements for service clearances, accessibility, and protection from physical damage. When negotiating with the inspector, it is crucial to present a well-reasoned and documented argument that supports the use of alternative methods. This argument should include a detailed analysis of the potential hazards associated with both the code-compliant installation and the proposed alternative. For instance, if extended poles are being considered, the analysis should address factors such as the pole's material strength, insulation properties, and ease of use in various weather conditions. It is also important to emphasize that the primary goal is to ensure the safety of qualified personnel who will be operating and maintaining the electrical equipment. Providing the inspector with technical data sheets, engineering calculations, and third-party certifications for the proposed alternative equipment can further strengthen the argument. Obtaining a variance from the local flood mounting ordinance can be a complex and time-consuming process. The application for a variance typically requires the submission of detailed architectural and engineering drawings, along with a written justification that explains why strict compliance with the ordinance is impractical or would create an undue hardship. The justification should clearly demonstrate that the proposed alternative solution provides an equivalent level of protection against flood damage and does not pose a significant risk to public safety. It is also important to consult with legal counsel to understand the specific requirements and procedures for obtaining a variance in the relevant jurisdiction. Contacting the AHJ can provide valuable insights into the local interpretation and enforcement of both the flood ordinance and the NEC. The AHJ can offer guidance on the specific documentation and approvals that are required for the proposed installation. It is often beneficial to schedule a meeting with the AHJ to discuss the project in detail and address any concerns or questions they may have. This proactive approach can help to streamline the permitting process and avoid costly delays. When considering the use of extended poles for operating the service disconnect switch, several critical safety factors must be taken into account. The extended pole should be constructed of a non-conductive material that is rated for the voltage and amperage of the service equipment. The pole should also be designed to provide a secure and reliable grip, even when used with gloves or in wet conditions. The length of the extended pole should be carefully selected to ensure that the operator can safely reach and operate the switch without having to strain or overreach. It is also important to provide clear and conspicuous labeling that identifies the location of the extended poles and provides instructions on their proper use. Furthermore, the accessibility of the extended poles should be considered. They should be stored in a readily accessible location that is free from obstructions. Training should be provided to qualified personnel on the proper use of the extended poles and the potential hazards associated with their use. Regular inspections should be conducted to ensure that the extended poles are in good condition and are functioning properly. In addition to the above solutions, it is also important to consider the potential impact of the flood ordinance on other electrical equipment and systems within the building. All electrical equipment that is located below the flood elevation should be listed for use in wet locations or should be protected by enclosures that are designed to prevent water from entering. Wiring methods that are used below the flood elevation should be suitable for wet locations and should be installed in accordance with the NEC. Ground fault circuit interrupter protection should be provided for all receptacles that are located below the flood elevation. The service equipment and the grounding system should be designed to minimize the risk of electrical shock during a flood event. The electrical system should be inspected and tested after a flood event to ensure that it is safe to operate. It is also important to develop a comprehensive emergency plan that outlines the procedures to be followed in the event of a flood. The emergency plan should include instructions on how to safely disconnect the electrical service, evacuate the building, and contact emergency personnel. The emergency plan should be regularly reviewed and updated to ensure that it is effective and reflects the latest information and best practices. It is crucial to remember that the safety of qualified personnel and the protection of property should always be the top priorities when dealing with electrical installations in flood-prone areas. By carefully considering all of the relevant factors and implementing appropriate safety measures, it is possible to ensure that the electrical system is both code compliant and safe to operate. Now, let's further discuss the specific NEC sections that are relevant to this situation. NEC 404.8, as previously mentioned, addresses the height requirements for switches and circuit breakers. This section states that the center of the grip of the operating handle of switches and circuit breakers, when in their highest position, shall not be more than 6 feet 7 inches above the floor or working platform, unless specifically permitted otherwise in the code. The purpose of this requirement is to ensure that qualified personnel can safely and easily operate the switches and circuit breakers without having to strain or overreach. The exception to this rule typically involves situations where the switches and circuit breakers are only accessible to qualified persons. In such cases, the height requirement may be waived, but other safety measures, such as the use of ladders or platforms, may be required. NEC 90.4, which allows for alternative methods and materials, is a crucial provision in this situation. This section states that the authority having jurisdiction may approve alternative methods and materials if they are satisfied that the proposed alternative provides an equivalent level of safety to the requirements of the code. The burden of proof is on the person proposing the alternative to demonstrate that it is safe and effective. To successfully invoke NEC 90.4, it is necessary to provide detailed documentation and analysis that supports the use of the alternative method or material. This documentation should include engineering calculations, test reports, and other relevant data that demonstrates that the alternative provides an equivalent level of safety to the code-compliant installation. It is also important to consult with the AHA early in the process to understand the specific requirements and expectations. In addition to NEC 404.8 and 90.4, other NEC sections may also be relevant to this situation depending on the specific details of the installation. These sections may include NEC 110.3, which addresses the examination, identification, installation, and use of equipment, NEC 110.26, which addresses working space about electrical equipment, and NEC 230, which addresses services. It is important to carefully review all of the relevant NEC sections to ensure that the electrical installation is code compliant and safe. Furthermore, it is crucial to consult with the local building code and ordinances to ensure that the installation also complies with all applicable local requirements. Local building codes and ordinances may impose additional requirements that are not covered by the NEC. In some cases, local requirements may be more stringent than the NEC. Therefore, it is essential to be aware of all applicable codes and ordinances and to ensure that the electrical installation complies with all of them. In summary, the situation described in the question presents a complex challenge that requires a careful and comprehensive approach. It is essential to understand the relevant codes and standards to communicate effectively with the inspector and the AHA and to explore all possible solutions. The goal is to find a solution that is both code compliant and safe, and that protects both qualified personnel and property. The use of extended poles should be carefully considered, and all safety factors should be taken into account. The building design may need to be revised to accommodate both the flood ordinance and the NEC requirements. Obtaining a variance from the local flood mounting ordinance may be necessary if a compromise cannot be reached with the inspector. By taking a proactive and collaborative approach, it is possible to overcome this challenge and to create a safe and code-compliant electrical installation.